So electricity is the foundation of electrical engineers. Another foundation of electrical engineers is computers. So the center is the processor. Think of it as a chef in a kitchen. Does all the work, has all the power, goes crazy sometimes is calm. So that's the heart of the computer. The chef right there, the CPU, that's the power. There is food that comes into the kitchen. Well, he has to get deliveries. Food that comes into the kitchen, those are inputs. Comes into the kitchen is an input. When we input something to the computer, we do it using the keyboard or the mouse. We input letters and circles and everything. That's the input. The food that comes into the chef, the chef works on it. Sometimes it gets hot because he's working so fast. And the output is the meal that he serves to the customers. And he might get in, I'm making this up, 100 pounds of food that day. But to be honest, he's not going to make 100 pounds of dinners. He might only make 30 pounds of dinners. You get the general idea. And so it comes out as meals. What's the output? The output would be something that you could print on a printer, or it would be something that you would see on the screen. You made something and you see the result on the screen. Now, I just said maybe you get a lot of food delivered, a large input, but sometimes the output isn't as big. And so the chef, if you've ever been in a restaurant kitchen, has a big walk-in box. It's like a monster refrigerator. So the stuff that's left over, so where it's stored is the walk-in box, and in computer terms, it's your hard drive. So be the chef, food input, dinners output, walk-in box for where you store everything, right? Instead of the chef, it's the computer, it's the CPU. The input is the keyboard and the mouse. The output is whatever you print on paper or see on the computer screen. And the hard drive is the storage. Okay, so with respect to your hard drive, it's really like a round magnetic disc, it's called a platter, in the middle of your computer. And it's divided up into billions of bits. Bits actually stands for binary digits. So there's millions of bits in your computer. So to understand how your hard drive works a little better, imagine that each of the bits are nails in a box. And if you remember that electricity can create a magnet, and a magnet created electricity, and the reverse is true. Electricity can create a magnet. So there's all these bits of information, think of them as nails. And when you straighten out all those nails, you can use those bits of information to store stuff. A binary digit means, binary 2, that bit of information can either be a 1 or a 0. And you're like, really? Like we send rockets into space with 1s and 0s? Uh-huh. Let's say, for example, the letter A. The letter A is stored as 1, 5 zeros, and 1. So in order to store the letter A, first of all, you have to get 7 bits that are not being used. The first bit stays magnetized. The next 5 bits are demagnetized. So there's nothing there, and they stand for zeros. And then the last bit stays magnetized. So the magnetized bits represent a 1, the demagnetized bits represent a 0. There you have the letter A. Now, of course, there are no nails in your computer, but these bits, I'm sure you've heard 20 gigabyte, 1 terabyte. A byte is actually 8 bits, but all you have to think of on your hard drive are these billions of bits of information. They can either be a 1 or a 0, and depending on how you put the 1s and 0s together, you can store everything in the world. So what's my point with all this? I'm sure some of you are watching and you're like, really? Like the nails and the bits and the bites? How is that gonna help my son or daughter or the kids sitting in front of me? I have done a lot of construction in my life, 30 plus years, from bare beams up. And I have worked with all kinds of trades. And I am very fortunate that I have never, ever, ever met a disrespectful tradesperson, ever. But in electrical engineering, there are about 20% of all engineers are female, but in electrical engineering, it's 14%, it's even less. So if you had a class of 25 students in an electrical engineering class, there might be 2 girls. It's even less in electricians. It's a 2% of 700,000. There are licensed female electricians. And the reason I'm bringing this up is I think everybody has watched television. You've seen a movie about cops, and so you think you can be a cop after 2 hours. Or we've all watched Law and Order, and we're absolutely sure, especially if we've binge watched Law and Order, we're absolutely sure we can be an attorney, whether it's a prosecutor or for the defense. We've spent, I don't know, maybe 15 minutes, might seem like an hour and 15 minutes, on electrical engineering. And I am sure that most of you are kind of aware of what it's about compared to what you knew about it 15 minutes ago. I just want to put a word out there. In my opinion, there are few people as imaginative and as resourceful and have as much style as high school girls of all descriptions. So I want you to imagine for a minute a high school girl, or perhaps a freshman, sophomore, college girl that has this information in her head. What a circuit looks like to make something light up. How a computer stores information. Or just even how you create electricity. I would love to see what they would do with that information. I imagine dorm rooms that look futuristic. Can you imagine, and I'm speaking to a lot of the females here, if you've ever done any work in your house or construction in your house, can you imagine for a moment that a female electrician came to the house? And maybe you're redoing the bathroom, I don't know, redoing the kitchen, oh my God. I want you to imagine for a second what the experience is like talking to a male electrician, which we've all done. They're in my family. And then what your experience would be talking to a female electrician, trying to lay out the outlets or the lighting in your kitchen. I just think, in my experience, electrical engineering would explode with the imagination that girls have. And that's what I want to bring to you. So on the next slide, I want you to see where electrical engineering crosses textile engineering. So this jacket is for the athletes in the last Winter Olympics, 2018 in South Korea. Ralph Lauren made them. If you look at the writings at the inside of the jacket, what they really were was paint that was put on the inside of the jackets, and when it was attached to an electric current, it kept the athletes warm. That's awesome. As I happen to ski a bit and my toes and fingers are constantly cold, I think it would be great to be a little toasty. Is it dangerous? Absolutely not. The voltage is so low that it wouldn't hurt anybody. But again, how the imagination of girls and boys, but now I'm just talking about girls, how it would run away with material like this and using their skill set. So next up is a short video on what electrical engineering is about from the pros, so to speak. What I was giving you before was just a taste of it for you to understand it on a deeper level. Now you're just going to watch a video and you're going to go, yeah. I want you to know that the video is made given the statistics that we have, that 86% of electrical engineers are male and 14 and change percent are female. Can you imagine what this video might look like if it was 50% female and 50% male? Okay, here we go.
Electrical engineering is a very broad major that encompasses a lot of sub-disciplines. Within the umbrella of electrical engineering, there are fields like RF, which is basically wireless communications, where you can work on satellite communications for defense purposes so the signal cannot be jammed by an enemy. There's electronics, where you could design the circuit boards within computers or phones, or the control systems within autonomous vehicles, or the circuitry in a prosthetic arm. There's power, where you'd work with high voltage systems and delivering or generating lots of electric power. There's controls, where you'd work on things that have some sort of electrical feedback, like propulsion systems in various aircrafts, all the way to your cruise control, where your speed is monitored, then depending on what it receives, the system turns the wheels faster or slower accordingly, which then affects your speed, which is then fed back into the system, and this control loop continues. There's instrumentation, which deals with designing sensors and equipment to measure physical quantities like pressure, temperature, motion, position, and so on. You could design motion detection sensors for a security system, GPS for aircrafts, or all the sensors in your car that have to analyze fluid levels, temperatures, battery voltage, anti-skid braking system, or more advanced systems for driverless cars.